In this question, we have truss structures A, B, C. And member AB and BC, they are in red angle shown here. And the theta is the angle between the member AC and the member AB. So in this question, the theta is equal to 55 degrees. So theta equal to 55 degree. Then we know this angle between the member AC and the member BC is 35 degree. And we have external node F here. So F is equal to 4 kilonewton, equal to 4 kilonewton. And the question is, what is the tension force in bar AC? So what is the force in bar AC? So let's start to work on these questions. So we will using the method of joint to solve this question. So the method of joint, we can start on the joint B. So for joint B, if we write down the free body diagram FBD of joint B. So this is joint B. So on joint B, we have external force F, 4 kilonewton over here. And also we have two member force AB and member force BC. So we don't know the direction of member force. So we assume the member force in AB and BC are in tension. So in tension, then the force is go outwards from the joint B. So this will be FAB. This will be FBC. So we assume it is in tension. So we have so on joint B we can write down two equations of equilibrium. So we have two unknown force. One unknown force is FAB. The other unknown force is FBC. So we can solve FAB and FBC. But first of all, we need to set up the coordination systems. So there are two ways to set up the coordination systems. The first coordinator system we can set up is that. So we set up the horizontal direction is X, the vertical direction is Y. Then we find the component of FAB, FBC on X and on Y direction. Then we can write down two equations of equilibrium, one on X direction, the other one on Y direction. So we can solve FAB and FBC. But here I want to set up the other coordinating systems to help us to speed up the process. So here is the procedure. So delete system here. So the coordinating system we set up, I would like to set up the X direction is on the direction of FBC. So this is X direction. This is Y direction. Okay. So from X direction and Y direction, we can find two components of the 4 kilonewton. So we can find two components of 4 kilonewton. So this component is 4 times, if this is the, so this angle is shown here. So this angle is 35 degree. Then this angle is 55 degrees. So based on this 35 degree. So then this is 55 degree. So this is then this for the component of 4 kilonewton in Y direction will be 4 times cosine 55 degree. And the component on X direction will be 4 times sine 55 degree. Okay, so then we can write down the equation of equilibrium in X direction. Fx equals 0, we assume, so go to right side direction is positive, so we can write down on X direction we have two forces. One force is FBC, so FBC go left, so it's negative, and the second force is 4 times sine 55 degree. Okay, so it's negative as well, so it's equal to 0. So then we know FBC is negative 4 sine 55 degree equal to 0. So we, oh no, this is the FBC. So we know FBC is negative value, so our assumption of member BC in tension is not correct because it's negative. So we say the member BC is in compression. So the value is 4 times sine 55 degree. So after we know the FBC, then we look on the joint of C, joint C. So this joint C, on joint C, we have reaction force. So this is reaction force. We say RC, and we have member force from BC. So member force from BC. BC is in compression, as we have to analysis is negative. So in compression, the compression that here, this is direction of compression. So compression, then the member forces go to the joint. So it's 4 times sine 55 degree. So this is member force in BC. And a member force in AC. So member force in AC, we'll assume the AC is in tension, because what is the tension force in bar AC? This is our question. We need to solve it. So this is FAC. So how to solve FAC? We can also set up the coordination systems. So we see the x direction go this way, the y direction is go this way. So if we can write down the equation of equilibrium in y direction equals 0, then we can solve FAC. We assume the positive direction is go up. So on y direction, we have two forces. One force is FAC, is go up, so it's positive. The second is the vertical component of this force. So vertical component is 4 times sine 5 degree. So what is vertical direction? So the vertical component here is this, and the degree is, we will know the degree is 35 degree. So then we know the vertical component will be 4 times sine 55 degree times cosine 35 degree. So this is the vertical component. The vertical component is in y direction and it's going downwards, so it's negative. So it's negative 4 times sine 55 degree times cosine 35 degree equal to 0. So then we can derive FAC is equal to 4 times sine 55 degree times cosine 35 degree. So this is the positive value. We got the result will be the 2.68 kilonewton. So this is the result. So this is tension force in bar AC. So that's all. Thank you.